Hello and good afternoon, everyone. Welcome to the Null Bhopal virtual meetup. And I hope you all are safe. So, this is Shreya Pohekar, and I'll be the host for this meet. So, if you are a bit unaware of what exactly Null is, let me brief a bit about. So, Null is a open community for security. It's open for all, free to attend with no restrictions. Who we are. We are one of the most active community in security with over 15 chapters running all across India and a few of them across the globe. Few of them examples are Null Amsterdam and Null Dubai. A member of Null. If you want to be a member of Null, you can be anyone from any profile. You can be a security professional or a student who is enthusiast about security, a penetration, or a developer who wants to learn secure coding or security manager or any of the domain that was not listed here. What we do, we eat, sleep, hack, and repeat. What we have in Null, we have basically four tracks under Null. The first being monthly meetups that we are having right now. The Hamla session that is red teaming, like offensive security. Then the Bachao session that is the defensive security or the blue teaming. And the Pulya session that is a session conducted in order to bridge the gap between the people of the community so that all of them are on the same page. So that is Team Null Bhopal, and that's me, Shreya Pohekar, and we have four other chapter leads: Shiraz Ali, Devansh Dubey, Laksh Dubey, and Devansh Devakar. So, what's in there for you? So, you get to learn a lot about security, not just security. You get to learn about technology. You get your exposure to the security industry because we are just not limited to Null Bhopal chapter because, like, you all are viewing it live right now. And it get to increase your network and you get your name out there. And the last thing happens when you come here and become a speaker. So how you can be a part of Null? So first thing, you can join mailing list where you can query about different things that happen in Null, and you get to learn from there because people are always willing to help you. You can attend meetups and workshops. You can register yourself on null.co.in because it maintains your public profile, like how many events you have attended or how many talks you have delivered. It's all public. So it's a good profile builder thing. And you can become a volunteer and help us find speakers and in organizing meetups. So that was basically Null. So since we are having monthly meetup today, we are having here two speakers. First one being Mr. Swaroop Yermalkar and the second being Harsh Botra. And I'm extremely delighted to host both of you. And introducing our first speaker for today, Mr. Swaroop. He is the head of cybersecurity red team at HackerU. He's also a project lead for OWASP, iGood project. That's a community project for OWASP. And he also freelances as a security researcher for SNAC Red Team. He also is a certificate holder of OSCE. So it's really a pleasure to have you, Swaroop, here today. And I want to wish you all the very best for your session. And you can now take over the mic.
Yeah, sure. Thanks, Shreya. So just let me share my screen. Okay. So before starting, I just want to confirm, can you see my screen?
Yes.
Okay. So welcome all. My name is Swaroop Yermalkar, and today I'll be presenting on stack-based buffer overflow. First of all, thanks to Null Bhopal for inviting me for today's talk. So as Shreya already introduced me, but a quick introduction of me. I work as head of cybersecurity team at HackerU India. And I'm also one of the instructor for master certificate in red teaming. In the past, I have worked with Philips Healthcare, Lithium, Traveloka. I have worked across different positions like road security engineer, then the lead road security lead. So I have worked across different locations and different positions. I hold a couple of certification and I'm frequent speaker at conferences and I have given talks in more than 10 countries. Uh, I'm also one of the top pen testers working with Cobalt. Cobalt is a pen testing as a service platform, and I'm rank one mobile bug bounty hunter at SINAC. I'm also author of two books in cybersecurity, and I don't know how many of you heard of OWASP iGoat. I'm also project lead for OWASP iGoat. This is free and open source project dedicated for iOS security. It's similar to you can say like DBWA or the other applications which you started learning with for web application security. Similarly, this is dedicated for iOS security. If you haven't taken a look at, just check this out. It's free and open source, and it can help you to learn the iOS application like breaking and security. And I have been acknowledged by a couple of companies for reporting critical security issues. Okay. And let's make this talk interactive. I know it's a Sunday evening, right? And it would be good if you can just tweet your feedback with Null Bhopal and Swaroop. That's my Twitter handler. Just what you liked in session. Not necessarily you should just write good, like whatever you liked about or how was the session. It will just like you attended my or today's session, and couple of you will get the free copy of this book, Learning iOS Penetration Testing. Okay, so just it's a giveaway. Okay, so let's start today's agenda. So today's session is completely going to be a practical. It's less theory. It just there will be one or two slides on theory, and almost rest everything is going to be practical. So we'll start with what is stack-based buffer overflow, um, how to approach the real-world application, how you can confirm the crash, what are the different fuzzing techniques, frameworks which you can use, how you can control the EIP, finding the bad characters. So I'm going to show you some cool techniques or the quick workarounds in which you can complete your exploit code and get the remote shell, you can say in a very speedy manner. Then we will create the different shell codes and ultimately we will do a remote code execution. So for today's session, I have taken the BrainPan machine in this track me. Moreover, we will learn the overall approach to develop the x86 exploit for any applications around there. Yes. So what is stack-based buffer overflow? So if you see the Wikipedia, it says stack buffer.
Hello, Swaroop. Uh,
Hello.
you were not audible for a minute.
Okay. Is it better? Am I audible now?
Yeah, yes, you are audible.
Okay. Okay. So this is more like a stack-based buffer overflow. You can say that let's say you have allocated certain buffer size and you try to write more data on the allocated size than it can handle. In that case, it can lead to the buffer overflow exploitations. Okay, so I'm going to show you everything practically. So let's not rely much on theoretical as of now. Okay, just a minute. So I'm not going to go into lots of theory like the instructions say the registers. It's a lot big manuals. Okay. Architecture, we have these certain set of instructions register set. And for x86, you can say that we have the general purpose registers, then we have the segment registers, we have the some flags registers. But the more important for stack-based overflow are ESP, which is a stack pointer, stack top pointer. The EBP is stack base pointer, and EIP is basically address of next instruction to be executed. So when we do buffer overflow, we basically control the EIP register. We give the address of next instruction. You can say we can basically point the program to our shellcode. And how we do that? We first basically fill the buffer with our payload, and then we find the jump ESP, that stack pointer, and then we give the address, you can say the stack pointer address to the EIP. So what will happen once the buffer overflow will happen? It will point to our shellcode. Okay, and we are going to discuss the different shell codes, how to generate the shell code, or what exactly the shell code is. Okay, so we are going to learn everything practically. Okay, so for this talk, I have recorded several demos. Okay, because I don't want to go into lots of configuration. Sometimes the VM gets crashed and all that things happens. So to avoid all of that, I have created all the demo videos, and we can just in the given time limit, we can complete all the demos and videos. Okay. So first of all, we are going to launch a machine in TrackMe. So TrackMe is, you can say, platform where we can just launch the machines in the cloud. And the machines, you can just click on activities, and we are going to launch the BrainPan machine. So of course, everything is free. You just have to do a free sign up, and you have to launch BrainPan 1 machine. And you can just click on deploy. So once you click on deploy, it basically deploy a machine in the cloud. And
Yes,
after 1 minute, yes.
Swaroop, you're not audible. Now you are audible.
Okay, I think there is a certain connection issue, which is weird. Okay.
Yes.
So, okay, just let me know whenever I'm not audible. Okay, so.
Sure, sure.
So basically, we are launching the machine, and once we launch the machine, all we have to do is just check the connectivity to the target system. Like you can just ping, and we can just confirm that are we able to connect or not. So we are all set. Okay, we have launched the machine BrainPan 1, and we are able to communicate to the target machine. Okay. I'll be using the Kali machine as, you can say, attacker machine. Okay, and in this way, this is the very first and basic step to launch the target machine. The second part in BrainPan, basically, you can explore.
You are not audible.
Okay, just 1 second.
Yeah, it's just breaking for a few seconds every time.
Okay, that's very weird. Hello.
Yes, you are audible.
Yeah, I think it's heavily raining in the Bangalore, so I'm not sure because
No
it's,
problem.
yeah, it never happens in connection issue, but I will check in some time. Um, so we will start with the enumeration part. As you can see that we will first start with Nmap. Of course, so my recommendation would be when you start doing the Nmap, you can just use the basic scan without any flags, because if you just try to include the flags at the first attempt, it will take lots of time. So the initial idea would be just start your scan and just check which all ports are open, which services are running. It will give you the overall idea of what is going on in target machine. And based on the ports and services, you can just open the port. Okay, you can see on port 10,000 there is a web is running. And if you do further directory enumeration using directory buster, go buster, FOV, you will observe that there is a bin folder. and there is exe which is on the in the application on the web server. Of course, I'm not going to show you lots of enumeration because this video is more of stack-based buffer overflow and not on the you can say reconnaissance or enumeration. And once you get the exe, you just have to save it somewhere on, you can say, just on your Kali machine or desktop. Okay, so lab setup, what we are going to do is we are going to have the Windows 7 machine as the target machine. Okay, the first is we are going to develop the exploit locally on the Windows 7 machine, and after that we are going to use that exploit against the print pan. So you can see on the left hand side I have the Windows 7 machine, and on the right hand side I have the Kali machine. And what we are going to do, we are going to copy the brainpan exe, okay, on the Windows 7 machine, okay, and we are going to generate the exploit. We are going to develop the exploit for the local setup, and then we will launch it against the cloud machine of brainpan. The first and very basic checks are checking the connectivity to the target system and checking if you're able to communicate with the target program. As you can see that BrainPan is running on port number 9999, and you can just check that it's showing welcome to BrainPan and enter to the password. And of course it will, if you just type any password, it will say access denied. Okay, so now we are going to examine, we are going to see if his application is vulnerable for buffer overflow and how we can use this exploit to exploit the application.
Your voice is gone.
Okay, it's okay, just a minute, then what we can do.
Oh, it's back now. You can continue.
Can you give me 1 minute? Maybe I can just disconnect and just I will
Yeah, sure, sure.
just give me 1 minute.
Okay.
Hello, can you hear me?
Yes.
I hope it will not break. I don't have, I'm not sure what is.
Hello. You are on mute, Swaroop.
Yes, yes, just give me 1 second. Okay, can you hear me now?
Yes.
Okay, I hope it will not break now.
Okay.
This is a lab setup I was showing to you. I have the Kali machine and I have the Windows 7 machine on the left side. And first we will develop the exploit locally, and after that we will just launch it against the cloud machine. So all you need is just the immunity debugger, and the exe has to be installed or has to be set on the Windows 7 machine. Is identifying the crash or confirming that application is getting crashed or not. Okay, so there are different ways we can use this spike. We can use the buffers for fuzzing, you can say, or checking if application is getting crashed or not. So let's see the demo. So what we are going to do is we are going to send generic send TCP. This is the way we use the spike fuzzing script, and you can see that the target application is getting crashed. Brainpan.exe has stopped working. Okay, and you can also observe the right hand side in Kali machine. It's saying couldn't TCP connect to target. Okay, it means we have crashed the target application. So this is also one of the way the spike using which you can fuzz the target application and you can find the crash. You can also observe this in the immunity debugger. You can just attach the exe, the process to the immunity debugger and send the crash here. Okay, and you can see that the EIP is overwritten with AAAs, right? 41. So 41 is basically A's in the hex, right? And you can see that we have successfully crashed the target application using this spike. It means basically fuzz different parameters for checking if its crash is happening or not. The next thing, it's also one of my favorite is buffers. In buffers also you can check the target application. You can just fuzz it for the target application to confirm if it's getting crashed. So I'm launching the buffer script and you can see that within a couple of seconds, the application has crashed and you can see that the buffers has already started sending the A's, B's, which is like 41, 42s. And it has also started working and it has showed that the target application is getting crashed after sending the bytes. So you can see that this is also very interesting, you can say framework for fuzzing. And of course, you can always observe this crash using the immunity debugger. All you have to do is attach immunity debugger and let's run it. And you can see that as soon as we run the fuzzing script, the application is getting crashed. The EIP is getting overwritten with 41, 41, 41, right? It means that we are able to override the EIP. So once we are able to override EIP, it means that we can control the flow of the application. So it's not in the special characters, the application may get crashed. So it totally depends on application to application, which parameters are vulnerable or where exactly you can say which parameters are vulnerable and which characters on which characters is getting crashed. So you can also take a look at buffers. After that, once we have confirmed the crash, the next thing is fuzzing. Like we don't know like after how many bytes or overall approximate how many bytes we have to send to crash the application. So we can also quickly make the Python script or fuzzing script where it will send the you can say that couple of A's and to the target application, and it can just give the approximate idea like how many bytes we should send in order to crash the application. So I'm just showing you the different ways of fuzzing in which you can just crash the target application. So here you can see that it's a while loop. We are adding the A's till we break the or crash the target application. So this is the Python script, and you can see that on the left-hand side, the target application is running. So let's run this script, the fuzzing script, and you can see that after 900 bytes, so the script sent around 900 plus A's, and after that, the application was getting crashed. Okay. You can also observe this in immunity debugger. It means that it can handle the buffer size is approximately 900 bytes. At this point, we are not sure that exactly how many bytes, okay, that we are going to learn in the next step, like exact how many bytes it takes to crash the target application. But here we got the overall idea, and we can also observe the same thing using the immunity debugger. So every time make sure you have attached the process to the debugger and your application is running. If you want, you can just keep the font size as 7. and make sure you play the program every time before you send the exploit code or fuzzing code. And you can see that again the EIP is overwritten, and in this way we have confirmed that after sending around 900 to 1000 bytes, the application is getting crashed. And here, so these are the register area. The right hand side is registers, and the right bottom is, you can say, this is the stack area, and this is the register, and this is the memory, and these are going to be all the instructions. So there are 4 sections in the immunity debugger, and here you can observe that EIP has been successfully overwritten with our A's. So this is the only way. These are the ways by which we can confirm the crash. This is the very basic and most important step before you start developing your exploit code. The next thing is, if you see in earlier demo, we studied like after sending almost 900 bytes, the application is getting crashed, but we don't know what is the exact offset or exactly how many bytes. So finding offset is nothing but finding exactly how many bytes the size of buffer is, and after which the application gets crashed. Okay, so let's jump on the demo. And if you see in the previous video, we had seen around the 900 bytes. After that, the application was crashed. So what we can do is, again, restart the program. And let's play the program.
Hey, you are not audible. Hello?
hello.
Hello? Yes, we can
Yeah,
hear.
it's really bad weather, and it's rare it happens like this. Okay, so just bear it with me. Okay.
Yeah, sure.
So so what we can do is we can just develop the basic crash.py, and we can see that. So this is the way. First, we will have the basic crash, and after that, we will develop our exploit on on top of that. So now what we are going to do is, rather than sending the age, we are going to generate the pattern. You can also generate the pattern using the MSF pattern, like using the Metasploit or MSF pattern from the Kali, or you can also use the online resource. So rather than sending the 1000 A's, let's send some pattern to the target application. So why we are doing this? We are basically finding after how many bytes the target application is getting crashed. We want the exact number. So that is like finding the offset. And now what we can do is again restart the program, and let's play the program. And now rather than sending the age, we are sending the MSF pattern this time, and it gave us some numbers in the EIP. So what you have to do is you just have to copy this number, and you have to write in this find the offset. And if you observe, the EIP is mentioning the address 3572 4134, and it gave us 524 as offset. So this offset is basically, you can say, the crash point. After this is the size of buffer. So after that, the target application will get crashed. So we can confirm that. We can just send the 524 A's, and then we can try to control the EIP, and we can confirm the application is getting crashed or not. Okay. So let's see how we can just control the EIP. So you can see that these are the 524 A's, which we are found using the offset, find offset, and now we are going to control the EIP. So now let's add 4Bs. We can just say 4Bs, and after the sending this exploit, let's observe the EIP. If EIP is showing the 4Bs, it means that we are able to control the EIP. So this step is only to confirm, are we able to control EIP or not? And here we go, you can see that we have successfully controlled the EIP with our bees. So 4242 is nothing but the bees in the hex. So 524 is offset. After that, we are sending the 4Bs and we are able to control the EIP. So it means that we are all set to develop our further exploit. Okay, the next step is finding the bad characters. Okay, so in many programs, certain characters are considered as bad characters like null or new line, which is 0x a, right? So in this step, we are going to find the bad characters. Okay, so we are going to use mona.py to find all the bad characters. Okay. So the first step in the previous video we had seen like how to control the EIP, right? We were able to do using the 4Bs. Now we will find all the bad characters present in the target application. Okay. So you can see the right hand side window, the terminal window where I'm saying mona config working folder. So first thing is setting the working directory for Mona, and I'm setting it to the C logs. And this is the place where we will have all our results from the Mona. So basically we are trying to find the bad characters using Mona.py script. It's available on the GitHub and it's basically from the Golang team. The first thing is Mona byte array. It will give the possible bad characters or it will list all the bad characters that could be possibly present in the target application. So what we can do is we can just copy that into our exploit. So now you can see that after the bees, we can basically send all the possible bad characters. So what we are going to do is we are going to compare the stack, or you can say the memory, or let's say stack after sending the exploit. So let's run this program and now let's send our exploit code. And of course, the B's are there, 42, 42 are there, but after that we have to observe. So you can see the stack, we already have the 524 A's. Then we have the B's, like 4 B's, which are mentioned. Now we have to observe our bad characters, which starts with the 00, but if you observe, there is no 01, 02, but there is no 01. It means that this is basically breaking the flow, or breaking the pipe. Okay, the other technique is using the Mona. We can use the Mona compare to compare the both values or the stacked values. So we can just say Mona compare, and we have to give the location clogs byte.array.bin, and we have to give the ESP address as -a, which we are going to compare. So which is 0022F930. So we can just compare that the address, and it says that corruption after 1 byte. It means the first character itself is a bad character. So 00 or null is basically bad character. So we have to eliminate that, and we can also note it down that the bad character is 00 or null character. Okay, so we are using the Mona compare to comparing the you can say stack, and we identified that the first character itself is a you can say the bad character. So after that, we again have to generate the byte array without the bad character. Okay, so what we can do is Mona byte array uh, -b stands for bad character, and this time we are generating the bad character without the null. Okay. And it gave us the so it will give us the list of you can say the bad characters, but this time there won't be 00 or null because we have generated the list of bad characters without null character. And now let's restart the program. Let's send our exploit code and let's see if there are any more bad characters into the target application. So let's send the exploit code and let's observe the stack. You can see there are 524 A's, there are 4 B's. And now let's compare. You can also do the manual inspection, like you can see the pattern 01, 02, 03, 04, right? So you can also do the manual observation and you have to check till FF, right? Till the end of the list of possible bad characters, starting from 01 to FF. And in this way, you can also find the bad characters, but this is the manual approach, but I would highly recommend to use Mona because in manual approach, you might miss certain bad characters. So, and this is the last character, so you can also observe the stack to see if there are any last character ending with FF, and you can see that it means that the only bad character is null or 00, right? Let's confirm this with the Mona compare. Again, we have to compare with the binary.bin and -a and the ESP stack pointer. And this way, Mona will tell us if there are any changes or it's unmodified the stack. And you can say the status or results of Mona is saying unmodified. It means there are no changes at all. So you can say that the only bad character here present is null bad character in the target, you can say for the target application. Okay. But it depends in many applications. There are many bad characters. There could be possibly 5 or 6 bad characters. There could be only one. It's totally depend. And I would highly recommend, you can use the manual as well as Mona compare for inspecting and eliminating the bad characters. The next thing is we know. So first thing we find out, we confirm the crash. After that, we find out the offset. So offset was after exactly how many bytes the application is getting crashed. Then we were able to control the EIP registers along with these. After that, we find out all the bad characters. In this case, only null was bad character, right? And now what we are going to do is we are going to find the jump ESP address. So jump ESP is we need to you can say point to the stack, right? So in that case, we will require jump ESP address. So again, we are going to use the Mona for finding the jump ESP address. So I want all of you to observe the right hand side Windows, you can say Windows task or the bottom of the immunity debugger. The first thing is you need to do the immunity, so Mona modules. It will give the list of all the DLL exes which doesn't have the protection like DAPE, ASLR or safe SEH, right? And we need to select that binary. And we are going to find the jump ESP address in that binary. Of course, there are different ways for, you can say the DAPE ASLR is basically randomizing of addresses. And there are different ways to bypass them. But for today's talk, we will not focus on the bypassing techniques. So this is the way you can say the getting started or the basic stack-based overflow. And we have selected the brainpan.exe and you need to find the command jump ESP. You need to find the address jump ESP in that exe. And you can see the address is 3117 12 F3. But because of Little Indian, we have to write in the reverse order, and that will be our jump ESP address. So it's going to be X F3 X F3 X12 X17 and X31. So this is our jump ESP address. So we can replace our Bs with the jump ESP address. So we can just write F3, 12, 17, and 31. Okay, it should be 31. So this is our jump ESP address, and the bad character we have already identified, which is the bad character. So we are almost set for the last step of the exploit development code. Okay. So the next step is the shell code. Okay. So I want to discuss brief before generating the shell code. So shell code, guys, don't get scared of the word shell code. Shell code is basically the program which you want to run on the target system after successful exploitation. Okay. So let's say you got remote access, remote shell, remote code execution on the target system, and you want to run the certain program on the target machine. So that program code is nothing but the shell code. So you can generate the different shell codes such as calculator, bind shell, reverse shell. Okay. So for proof of concept testing, we can also have the calculator shell code, which we are going to learn. But in most of the cases, the reverse shell, which attackers do, are the reverse shell code. So in brief, if you just want to understand, the shell code is the program which you want to run on the target system. Okay. So let's see how we can generate the shell code. So I'm just going to repeat a first we are going to send 524 A's because this is the offset. Then we found the jump ESP address, and now we are going to generate the shell code. So we can use the MSF Venom from the Kali Linux to generate the shell code for calculator. And you can see that I'm generating for x86 architecture because the target operating system is 32-bit, and I'm generating in the format Python. And the bad characters, if you remember, we have already identified the bad characters as null character. So while generating the shell code, we will make sure that this bad character is eliminated or it's not present in the final shell code. And this is the variable value which I will be using for in my exploit code. So all you can do is just generate the final shell code. So this shell code is basically, you can say just, it's a calculator program, the instructions for the calculator program. And you can just copy that, right? So this is our calculator shell code. This is just for proof of concept. And once we confirm it's working fine, we can just go for reverse shell. We can also add the couple of nope slides. Nope slides is basically, it means do nothing. It means it's just required for, you can say, jumping to our shell code. When we load, when the shell code is in the stack, we need to point the execution to our shell code. So that's the reason we have to add a couple of nope slides. And guys, you can see that we have successfully sent our exploit code, and we were able to run the calculator program on the target system. Okay, this way we confirm that our exploit code is working all fine, and we were able to invoke the calculator application on the target system using the brain pan. Okay, but this is no use. Okay, because calculator, let's say you have the target machine, what you will do of invoking the calculator, you will need to get the shell level access of the target system, right? So that's the reason we are going to generate the reverse shell code. Okay, in which we will get the reverse shell after the successful execution of our exploit code. So let's jump on the demo. Now we will just replace our calculator shell code for the reverse shell code. So we are going to generate the new, we're going to save this as a new file, reverse shell.py. And the only change which we are going to do is we are going to generate the shell code for the reverse shell. Okay, so for that we will require the IP of attacker machine, right? You can say my reverse IP is going to be 198.168.0.114. So in reverse shell, basically the target system connect backs to the attacker machine, and for which we will have to give the reverse IP and the port to which the target system or victim system will get connected. So again, I'll be using the MSF Venom and I will be using the shell reverse TCP as a payload. But here I'm going to mention the your host, my Kali machine's IP address, local IP address, because the reverse connection is going to connect back on this connection and this port. So using the L port, you can also mention the which port you want the connection back. And here I'm selecting 123 port. This is the A stands for architecture, and then hyphen F is basically which format you want your final shellcode. And then the which are the bad characters. This is the very important step to mention all the bad characters. If you miss any bad characters, in that case, your exploit will not run on the target system. So it's very important to add all the bad characters while generating your shellcode. And once we enter the command, it takes a couple of seconds to give the final shellcode. So now we will just replace the calculator shellcode along for our reverse shellcode, and let's see the results. So I hope everyone is now familiar with the shellcode. Shellcode is basically the program which we will execute on the target system after successful exploitation. So this is the shellcode for reverse shell. But before running the shellcode, you need to make sure that you have started the listener. As you know, this is a reverse shell. There will be connection back to our system. So first thing is starting the netcat listener on the given port. Okay, so the port number is 1234. So NC is netcat, and we are listening on the port 1234, and we are all set to send our exploit to the target system. And you can see that let's observe the reverse shell, and guys, we have got the reverse shell on the target system, and now you're all good to do any commands, directory listing, navigating to different directories. But I would like to remind you that the exploit which we have developed is only for local machine. And if you remember where we had started, the ultimate goal is basically the brain pan machine, which you are going to exploit using the buffer overflow, right? So in the next step, we are going to make some changes in the final exploit code as per the brain pan machine IP address. Okay, so let's jump on the demo. So now our exploit code, what we did is we have successfully exploited our local system, local Windows machine using the brain pan, but our ultimate goal is exploiting the machine on the triagram and getting the reverse shell of the triagram machine. So in this case, we will just have to change our payload, because our IP address, the reverse IP address will get changed, because we will be over the VPN, and we will have to mention our VPN IP address in terms of getting the reverse shell. Okay. So now in this step, we are going to see to exploit BrainPan. So if you see the target IP address in BrainPan is 10.10.184.140. So this is our ultimate target, which we are going to exploit using the BrainPan system. So now let's create the final exploit code file. You can say the remote underscore BrainPan. So now in this case, we are just going to change our final shellcode and the target IP address. So here the IP address will be of the target machine of BrainPan, which you can mention in our exploit code. And also the reverse IP address will also get changed. So while generating the payload or shellcode, we will have to use our VPN IP address for reverse connection. So we can just check our tunnel IP address, and based on that, we can just mention, or we can generate the final payload. And you can see the tune0 IP address is 10 to 1530. Now you can just generate a new reverse shell code with this change of IP address. Okay. So this is the IP address of my system or attacker system in the VPN. And again, the rest of the things are going to be same. The bad characters are going to remain same. The listener port also you can keep the same. And you can see that it has given the shellcode. Let's copy the shellcode and let's save this on the target system. Let's save this in the exploit code and let's try to run it. But again, make sure always you start the listener before sending any reverse shell code. Otherwise, your exploit get failed. So let's send the final exploit, the reverse shell remote brain pan, and make sure your listener is on in another tab. And let's hope that we will get the shell. And here we go. So we got the reverse shell of brain pan, which is deployed in the cloud of TrackMe. And here we can just see what all things are there. We can just navigate. If there is any flag, we can also try to copy the flag from that system. And we can see that there are different users, and in many cases there will be some flag on the system, and this way we can basically just copy that flag, and we can also try to get verify that we have successfully gained access to the remote system. So you can see that we have completed the room, the brain pan room. So these are the basic steps. I will just quickly do a recap. I hope we still have the some 5 minutes. So what we can do is we can just quickly do a recap, and I want to explain you the steps. Okay, so if we go back to agenda, I will just revise whatever we seen from the first slide. Okay, so we first theoretically we saw like what is a stack-based buffer overflow. After that, we confirm the crash. We use the spike. We use the buffers. This is very important step because in a real life application, or even if you're taking the, let's say, one server which has the multiple, you can say the commands, and it's very important to find the vulnerable command or which input parameter or the starting point for our exploitation. Okay, so you can use the different frameworks like spy, buffers for fuzzing or for confirming the crash. Okay, when I used to develop the exploit, I have also seen that certain application gets crashed with the special characters. Okay, it's not always necessarily that only A's, B's will crash the application, only characters will crash. So it's very important that how strong your fuzzing is. So this is the most important part before you start developing the exploit code. And once you confirm the crash, you need to find the offset, like how many bytes the application is, you can say, manage or handle, and after how many bytes the application is getting crashed, right? So in our case, we were able to find offset as 524 bytes, after which the application was getting crashed. And of course, you can, after that, we were able to confirm the EIP. So in the buffer overflow, the main, you can say the main control is EIP. If you are able to control the EIP, we can control the execution of the application. So throughout this exploration, we just have to focus more and more on the EIP register. And you can, if you remember, we were able to control the EIP without beats, like 42s, right? Finding the bad characters, I would say this is the most, again, all the steps are most important, but this is a bit tedious because it might be look difficult initially, or it might take some more extra time of you to find the bad characters. You can use the monapy, or you can also use the mona.py, or you can also use the manual inspection of the stack to find the bad characters. Okay, in many applications, I have seen there are almost 8 to 10 bad characters. Okay, so it's up to application. But if you're not, if you miss any single bad character, then your final shellcode will get failed. Okay, because if you remember, while generating the shellcode, we had eliminated all those bad characters. So if you miss even one bad characters, then your final exploit will not run. And after finding the bad characters, we were able to find the jump ESP. Again, we use the Mona to find the modules which doesn't have the certain protections. And then we were able to point the stack, point the EIP to our, you can say, shell code or exploit code. And we studied that the different exploit shell codes, like calculator is like, you can say, proof of concept. If you look at the different exploits on exploit DB, you will see that there are certain exploits which says just to pop up the calculator, okay, just for proof of concepts. But of course, in real life, you will require the shell access to get the flags, or of course, to get the remote code if you want to execute certain commands on the target system. So first we started with the calculator shell code, and after that, in the end, we studied the reverse shell code. And once our expert code was working all fine locally on our local setup, we just change it for running it on the brain pan machine in the TrackMe. Okay. So this is just the basic starting. There is a lot more in stack-based buffer overflow. You can say there's a DAPE, ASLR protections, how to bypass that, what is pop return. There's so many things, but this is, you can say, this is the way you can getting started with for your exploit development or exploit development for stack-based overflow. Again, there are also a similar, you can say, the similar variations in Linux x86, where we can use the GDB for checking the register values, or finding the, or even the, you can say, observing registers and controlling again the EIP in the Linux x86 as well. Okay, so I guess that's all I have planned for this session, and I hope we are almost in the time. And I would encourage you to try this out. Okay, try out this remote code execution on the brain pan. This is the free room on the TrackMe. You don't have to pay anything. Okay, and let me know if you come across any problem, and if you, yeah, in case you can also tweet me, or in case if you have any questions, if it doesn't work out, you can also send me email, or you can just tweet me, or you can message me on the Twitter, and I will make sure to reach you out. Okay, Shreya, so are we going to have the QA session, or how it's going to be?
See, there were a few questions over YouTube comment section. So like one was asking about what is EIP.
Okay. So EIP basically holds the address of a next instruction to be executed. Okay. So when the program executes, the execution is line by line, right? And EIP basically says, okay, after this instruction, I'm going to execute this instruction, like the next instruction. And in buffer overflow, we basically point EIP to our shell code, our malicious code, and we say that rather than executing these instructions, execute or point or run my shell code. So EIP is basically, you can say, the next address, next instruction to be executed in your execution flow.
Okay. Here is another question, a bit off topic. But yeah, on topic. What OS is mostly used by professional hackers, whether Windows or Mac?
Yeah, this is everyone's choice. As you see, for exploit development, Kali, everyone knows that, right? The Kali machine already has so many for buffer overflow or even the exploit development. I use the Kali, but I would recommend Kali because it has everything you need for developing the exploits. But again, it's your choice, like Windows, Linux, and Mac.
Okay. And there was my question only. It was like, what do you prefer more, Ghidra or IDA?
I use more. You mean the IDA Pro, right?
Yeah.
Yeah, I'm comfortable with IDA Pro, and mostly I use the IDA for all this debugging or disassembling of the code.
Okay. Okay. Great. Okay. So rest all questions that were asked on the YouTube comments are already answered by you. Uh, could you could you crash application with Python? There's another question without Kali.
Of course, see, Kali is, you can just say I'm using as a base, as an attacker operating system. but it's just a Python script. You can send it from Linux, you can send it from Mac, you can send it from Windows. It doesn't matter at all. Okay, it's just a Python script. It's just a piece of code to crash the application. So even if you have the Windows, Linux, anything, even if you have the mobile phone and you have you can say if you're able to capable to send the Python script, of course you can the target application you can crash it. All you need is just the Python script or the exploit, the crash code, right? And it's really up to you how you or from where you want to send it to the target system.
Okay, here is one more question. Can you name one debugger that you were using? Can you name? Yeah.
I was using the immunity debugger. You can also use the Oli debug, immunity. So immunity, Oli are very pretty much similar. I was using the immunity because it has lots of extensions for Python support for as part of extensions.
Okay.
And of course, if you're using the Linux, if you're developing the exploit code for the Linux, you can use the GDB as a debugger to observe the registers and other values.
Yeah. Okay, then we have no more questions. So that.
Yeah, Aaron, thanks for inviting me. And I'm so sorry. In Bangalore, it's very, very bad weather today, and maybe my connection
No, at
was
the end it was all good. It was just in the starting. No problem.
sure.
Okay, so I want to thank you, Swaroop, for this amazing session, and thanks for like taking it in the demo part because the theory would have gone over the head really. So
Yes.
always practical makes sense. For the audience, if you have any further doubts, you can surely reach out to him. His Twitter ID is on the screen. And yeah, thanks everyone for joining in. So for the next session, we have broken cryptography and account takeover by Harsh. So you can join in the second link and we'll be live there again now. So thank you and have a good
Yeah.
day.
Thanks, everyone. Thanks, everyone.
Thanks, Swaroop. Bye.
Yes, thank